Hey guys, welcome. This is the 10.3 worksheet, so let's go ahead and get started. It says each regular polygon has a radii and apothem as shown. Find the measure of each numbered angle. So we have all these. So what we want to remember is we have 360. Let's get this into a pen. So we have 360 degrees is the central for this whole thing all the way around. And we can count the sides 1, 2, 3, 4, 5, 6, 7, 8 sides. So if we divide this by 8, that will give us the measure that we need for this. So if you actually divide that by 8, you get 45. So each one of these angles in here is going to be 45 degrees, or the one I have in blue. So angle 1, 45 degrees. And then if we want the angle 2, that's going to be half of it, the apothem right there, which is the name of the perpendicular piece. So the apothem right here in yellow. So that's the apothem. Cuts that 45 in half. So if I cut that in two, I'll get about 22.5 degrees right there, which I just realized is a horrible color to use. And then we have 22.5, and then we have a 90 degree right here. So if we do 22.5 plus that 90 degree plus whatever this angle 3 is, just call it the measure of angle 3, that should equal 180. And so if we just grab our calculator, which I have a calculator already, we just take 90 and 22 away from 180, and we should get 67.5. So first thing is we want to find those angles by taking care of that. So it's kind of like our first little guy right there. All right. Find the area of a regular polygon with a given apothem and sides round to the nearest hundredth. Okay, so as we know, we have our formula. Area equals 1/2 apothem times perimeter. And if the apothem is given to us, it's really easy, and we have our side, we can find the perimeter. Pentagon's 5, so we just do 7.1 times 5, and that should give me my perimeter. And so if I calculate that out real quick, and we do 7.1 times 5, we get our perimeter is equal to, sorry about that, 35.5. So we have our perimeter, and we have our apothem, so we just have to multiply all together. So we get area equals 1/2 the apothem, which is 4.9, and then times the perimeter, 35.5, and we just go ahead and calculate that, which I'm going to do right now on my calculator. So 35.5 times 4.9, and then divided by 2, and we should get, for this guy, 86.975, so we'll just call it 86.9, and that's in square inches. So I kind of not a lot of space for these. So the first thing we want to do is basically find the perimeter, and then we're just going to multiply the apothem times the perimeter, divide by 2. So the perimeter, hexagon, so we're just going to do 14 times 6 for our perimeter. So we get 84 for the perimeter. So a lot of times I just go through these, do the perimeters first. So that's 17.2, really times 8, that should give me my perimeter. 137.6 is my perimeter. To underline them. And then this is 37. Nonagon is 9-sided, so my perimeter is going to be 37 times 9. So 333 equals the perimeter. And there we go. So we have our perimeter for all three. Then we just have to go back and just calculate it. So it's apothem times perimeter. So I'm going to do 12.1 times 84 divided by 2. And so sometimes I'll write it like this, which is, this is 84, sorry, and just divide it by 2 like that. That's the same pretty much as this guy over here. So 12.1 times 84 divided by 2, and we get 508.2 square feet. Thinking over here, we're just going to do 20.8 times 17.2 and divide it by 2. I'm sorry, not 17.2. Where is the... Do we have an eraser? Yes. That is a side length. I want the whole thing. So I will correct that. That should be 137.6. My bad. So 20.8 times 137.6, and then divide by 2. So my answer should be 1,431.04 square meters. Kind of like the pink, guys. It's looking good. All right, so 50.9 times 333, and then divided by 2. That's a big number, isn't it? 8,474.9 square meters. Again, everything's squared because we're talking about area. Yeah, brother. Okay. Let's continue on. Moving on down. Okay. Find the area of the regular polygon. So with this one, I like how it kind of breaks it all down into little pieces for us. So let's find each one of these. I'll use purple for the central angle. So the central angle is pretty easy. It's just 360 divided by the number of sides. So 360 divided by 5. Oh, come on, Ryan. I sometimes talk to myself. I should say Mr. Smith. So central angle is 72. This one, it's 360 divided by 3, which that's 120. Okay, so I got my central angle. Perimeter is pretty easy, just 9 times 5 here. So it's 9 times 5. I got that one, 45 millimeters. And then this one is 17 times 3, which I'm cheating. I'm doing it 51 feet. Okay, then the area, now we want to use our formula. They're giving me the apothem already. So we have the apothem here. So we just really have to do this times the perimeter, this times the perimeter, and divide by 2. So let's do our final answer in, what color have we not used yet? I like the pink. Let's try the green. I feel like the green might not be good. Okay, so we're going to do 6.2, that's not bad, divided by 2 times the, so 45 times 6.2 divided by 2, 139. Nope, doesn't like that. That was weird. 139.5. I'm using a different tablet, so it's a little mysterious on how it's working. But overall, it's working okay. So apothem, 4.9 times the perimeter, 51 divided by 2. Oh, boom, booyah, 124.9. And again, we should put units of measure on here, feet squared, and this is millimeters squared. All right, cool. How long is this? Oh my god, it just goes forever. Why? Just kidding. Oh, we only got 6 more. We are chilling. Okay. So this is going to get a little bit harder. I think. Because we don't have the side. So we have the apothem. So I need to find a side first. And this one we don't have the apothem. So let's do the central angle first. How do we do the central angle? What color do we use? I'm just going to do green. So 360. In this case, we're going to divide by 6. So that will give me, I believe that's going to be 60. So central angle 60. Over here is going to be 360 divided by 3, which is 120. So in the other problems, we didn't have to use the center angle, but what we're going to do is we're actually going to draw this little triangle right here, and I'm going to draw it out. Booyah. So this is 15 right here. That's our apothem. We want to actually find this guy right here, which is this leg. And we're going to be able to do that pretty easily, actually. But if we were to draw more triangles, so we know that in each one of these triangles, it's 60 degrees. But that apothem is going to cut in half, so that makes this 30 degrees. Well, this is a special right triangle, and not to brag, but I know how to do these. Across from the 60 is L rad 3. This is L, and this is 2L, but that doesn't really matter. So if I want to go from L rad 3 to L, I have to divide by 3, multiply by rad 3. So this is actually 5 rad 3. So I actually know this blue piece is 5 rad 3, but that's not the side length. We're going to have to double that because it's half. So we're going to double it. That's going to be actually 10 rad 3. And since there are 6 sides, so I just doubled it because that's also 5 rad 3, and 5 rad 3 plus 5 rad 3 is 10 rad 3. But then we have to multiply by 6 sides, so the perimeter is really equal to 6 times 5 rad 3. I'm sorry, 10 rad 3. So that's going to give me 60 rad 3. And now let's put our answer in pink because everything's pretty in pink. We take the apothem, 15, times the perimeter, 60 rad 3, and divide it by 2. Now, actually, just leave the rad 3 in my final answer. So I'm just going to do 15 times 60, which is going to be 900, divided by 2, which gives me 450. And I'm just going to do 450 rad 3, and I'm going to put that in square inches, and I'm done. So let's do the same thing over here. We break this into these guys, and we got these as 120, but once I put my apothem in, that's going to break in half into 60. So I have this kind of longer triangle. This is going to be cut in half, so this is only 13 and 13. So we get 13 on the bottom here. This is the apothem, which we don't know. And this is going to be 60 degrees right here. And so again, I get, it would be an unfortunate number, but L rad 3. And this is going to be across from the thing, so that's L. And so we want to divide by 3, multiply rad 3, which means the apothem is going to be actually 13 rad 3 divided by 3. So divide by 3, multiply by rad 3. So there's my apothem. My perimeter is just going to be 26, right? Times 3, because we only have 3 of them. So we get 78. And then we just multiply those two and divide by 2. So I'm going to do 1/2 of 78. Notice I'm not doing it like I did on number 10 because I have that 13 rad 3 divided by 3. So I just actually do half of 78 first. I just like to piece it apart. 39, and then 13 times 39. I'm going to do that next. And then I'm going to see, so that's 507 rad 3 over 3. Let's see if that's divisible. That would be so convenient. It is. So we get 169 rad 3, and that's in square feet. Killer. All right, so those ones are definitely more challenging because we're not just given a side and an apothem. We have to use some special right triangle math. But guess what? We could do it. Okay, FOMO. Let's do this. Okay. All right, so this one, let's get to it. What am I doing? What am I doing? I want to, go back to pen. All right. So let's get our central angle. So 360, we have 4 sides. Oh gosh, what was that? I'm afraid if I hit clear screen, I'm not going to like that. So I'm just going to erase this. That's weird. Okay, so 360 divided by 4. That should be, I want to say it's 90. Like really positive. It's 90. It is 90. See why is it doing that? That is weird. I have to erase that. So this is 90, but we're going to break it into a smaller triangle where this is going to break into 45, 45, which is very convenient for me. What? It does not like whatever is going on with this, so it's just... Okay, let's try a little bit better. There we go. Okay, so 45, 45, 90. Now 8, if we were to break this down like this, because it might just be easier, that's the hypotenuse. What the heck? Maybe it's just the green is not good. All right, I heard there's a button on here, and if you press it, it ruins your life. That's probably what it is. Okay, so this is LRAD2. We want L and L. So we divide by 2, which gives us 4, and then multiply by rad2. So we get 4 rad2 and 4 rad2, which is great. So we want 4 rad2. Can I zoom out a little bit? Nope. Why does my finger work? It should not work. That's probably what's happening. My hand's touching it. Okay. Get out of here. So 4 rad2 is our, let's see if we can zoom down just a little bit. Okay, so our sun triangle we said was 90. Our apothem is actually going to be this piece right here, which is 4 rad2. But this is only half our side. Remember, this piece right here is 4 rad2, but we want to go the whole thing, so we got to double it. So that should be 8 rad2. So we just double it, we get 8 rad2 if we double it. And then for the perimeter, it's four sides, so we're just going to do 8 rad2 times 4. So 4 times 8 is, what, 32 rad2? And then if we just take the perimeter and the apothem, multiply them, and divide by 2. So we get 4, oh yeah, don't do that color. 4 rad2 times the perimeter, 32 rad2, and divide all that by 2. Now the rad2 is going to make 2, and then we're going to divide by 2, so it kind of cancels that out. So I really just have to do 4 times 32, but you plug that whole thing in, you should get 128. And I forgot what our units of measure were, but we can figure that out real quick. It was centimeters. So we got square centimeters. There we go. Okay, mouse it up. All right, so we have a hexagon. Now, we already did a hexagon. I'm going to show you a little fast way of doing this. A hexagon, remember, is a 30-60. So 30 is at the top, 60 at the bottom. So you can almost go straight to this triangle, which is what I'm going to do because it saves me a lot of time. So I'm just going to automatically go to the 30, 60, 90 triangle, where this is half the side. So this is 14 down here. And then I'm looking for the apothem. And so this is really easy, this one, because this is giving me L, and I need L rad 3. So I kind of already know the apothem very quickly on this one, which is going to be basically 14 rad 3. And then 28 times 6, which is going to be 168. By the way, the center angle was 60, which we then took half of it to get that angle, 30 in there. And then area, we just do perimeter times apothem. So I'm going to just do 168, which is the perimeter times the apothem, 14 rad 3, and then divide by 3. 2. That's a 2. That's what I meant to say. So 168 times 14 divided by 2, it's a pretty large number. We're going to get 1176, and that's going to be rad 3, and that's square meters. Okay. How are we feeling? Feeling good about that? Let's see. Uh-oh. Split the screen. My bad. My connection was interrupted. Okay. Sorry. All right. Let's continue on and move on. Okay. Last two. I'm not going to go over these, but it's factoring stuff. Good stuff. Okay. So again, I'm going to cheat these real quick because I've already done the triangle. I already know when I set up this guy, which that's giving me the apothem there. So this is 8.5. I don't know why that's there. Let's just get rid of that. That's probably left over from the last problem. And So we got 90 right there. This is going to be a 60 degree. If you don't believe me, our central angle is going to be 120 divided by 2, which is 60 in there. And this is in my 30 positions. This goes a lot faster if you know your special right triangles really quickly. Across from 30 is L. This is L rad 3. So we're going to get basically 8.5 rad 3. So 8.5 rad 3 is this piece right here. But remember, it's this second piece too. So we actually have to add 8.5 together to make the whole side. And so if we do that, that's going to give me, what's 8.5 plus 8.5? That's what, 17, I want to say? I'm going to double check that. It is. So one side's going to be 17. 17.5, and our central angle is 120 divided by 2. That's how I got that 60. The perimeter, that's 7.5 rad 3, by the way. Now we have to multiply that by 3, so times that by 3. And why it wasn't 17.5? I'm sorry, just 17. 17 rad 3. Let's do that again. Let's do it again. 17 rad 3. And then we're going to multiply that by 3. 3's don't come out good on this. 17 times 3 is 51 rad 3. And then we just do 51 rad 3 times the apothem, which was 8.5. Maybe it's my 3's that are not good. Okay, and I got 216.75 rad 3. Now, typically, we probably don't usually leave it like that. But in this case, we're going to leave it like that. Okay. Whew, last one. We got this. Okay, it's another hexagon, which we already know from the one we did up here. It's going to be a 30 up there, so we're going to do a 30, 60, 90 again, which I'm hoping is going to make this really easy. Let's go pink, because I feel like we do really good when we do pink. All right, so we know this is a 30 up here, because the central angle is 60. This is 5.5 rad 3, which is in the good news is this is in the L rad 3 position, which this is L, which makes that just going to be 5.5. But remember, this is only talking about this piece because we're really looking at this triangle right here. So I have 5.5 here, I have 5.5 here. Add those together, that's 11. So we have one side is 11. Perimeter, multiply that by 6, because we have 6 sides. And that is 66. And then we do 66 as our perimeter times 5.5 rad 3, which is our apothem, divided by 2. So 66 times 5.5 divided by 2 is 181.5 rad 3, and that is square meters. Oh, yeah. All right. Thank you. You guys did great. Bye-bye.